Okay, hi everyone, so I'm Bibiana, and today for this bonus 2 assignment I decided to go with this trial, which was a randomized trial of pulsating corticosteroid therapy for primary treatment on Kawasaki disease. It was published back in 2007, and for those who are not familiar with Kawasaki disease, it's an infantile disease uh, which is an inflammatory condition in which vasculitis, especially of the coronary arteries, happens. When left untreated, this patient, up to 25% of them can develop coronary aneurysms. And when you give them treatment such as IGIV, which is a standard of care, along with aspirin, this proportion goes down to 5%, 4%. So lately, in the past years, we've been wondering whether we need to be a little bit more aggressive in the initial treatment to reduce these chances even more. So I think that that question actually began for me last year with a few patients who who were hard to treat. Um, and well, actually, I found this trial last year. At that moment, I think I understand almost half of the things I understand today after finishing Model 2 of the PPCR course. And so when I decided to do this for the bonus 2, it kind of took me back to that 11th of July when we had the second exam. And I figured out that despite they were exam questions, they were good questions to go through with the analysis of this particular or any paper at all. So I decided to use the questions we were given for the exam to help me analyze and go through with this trial and try to explain it the best way possible. So, a little bit about the design. It's a multi-center randomized double-blind placebo-controlled trial. This is an RCT, which is, I think, it's a very good study design for these sort of questions. RCTs have a great deal of power, and they usually have high levels of evidence to make inferences on causality. So I think it's a good design for this kind of questions. So this detailed information is further into the methodology part, the section, but I'm going to say it here so it's easier to analyze. There were 199 patients recruited, 101 went to the intervention group, which received IGIV plus aspirin, which is a standard of care. This disease is not ethically correct to leave untreated. So all patients receive standard of care, which is IGAV plus aspirin. But the intervention group received as an add-on methylprednisolone. And the control group only received the standard of care, which is IGAV plus aspirin and placebo. Okay? So question one was, what are the main primary independent and dependent variable? So the independent variable we kind of already mentioned. This is an experimental design in which we have two groups, intervention and control group, which is categorical. Since there are two options, you can also say it's binary or dichotomous. Okay, so the independent variable is a categorical one with two options, binaries or dichotomous. The dependent variable is a little bit more difficult, but here the outcome was to assess and evaluate how coronary arteries were impacted by the disease. So for us, the way to do it is with measuring coronary dimensions. In this, the authors measures these coronary dimensions with the echocardiogram. Okay, they did it at week 1, which was baseline, and at week 5, which was 5 weeks after treatment, and that's the moment when you kind of decide whether a patient developed a disease on the coronary arteries or not. So we measure coronary dimensions. The authors, when you do it, you measure millimeters, how many millimeters a coronary has. And then you can adjust this for body surface areas and you get the Z score. Here, and I'm going to say something that is related to another outcome. The authors had like two primary outcomes. The first primary outcome was to assess the coronary dimensions, both in absolute dimensions, which is 3 millimeters, 4 millimeters, 5 millimeters, 10 millimeters, and the set score, which is adjusted by body surface area. Okay, a set score could be like 1.5 to 2.1, 2.3, 2.2. Okay, so both of these absolute dimensions and the set score are continuous variables. Both of them were the first primary outcome for this trial, which means that the dependent variable is a continuous variable. Okay, these numbers, this absolute dimension and the set score, are numerical variables. To be more precise, continuous one, because the spacing between them it's meaningful. So here the authors mention how they did this. They did the echocardiograms, they measure all the coronary arteries that they could measure, the left main, the left anterior, the circumflex, the posterior. And here comes the second part. I just said that there were two primary outcomes. The first one was the dimension of the coronary arteries in absolute numbers and set score. And the second primary outcome, it's this: the presence or absence of aneurysms, according to criteria on the Japanese Minister of Health. The second primary outcome is a categorical variable. Here the authors try to classify whether patients had aneurysms, yes or no. So it's a categorical, dichotomous or binary variable. Okay, so there were two main primary outcomes. With all of this information, we can fulfill the PCOT sections. For population, it's Kawasaki disease patients, which meet the diagnostic criteria and then the inclusion and exclusion criteria for the trial. The intervention group was the standard of care plus the intervention, which was methylprednisolone. The control group was just the standard of care plus placebo. And the outcome were two primary outcomes: the coronary artery measurements in absolute values and set score, and the other primary outcome, which is the development of aneurysms, yes or no. And the time was 5 weeks, because we had the measurements at week 1, which was baseline, and they evaluated the effect of this intervention at week 5 to see whether the patients have gone well or not in this outcome. So, as I was meant to use the questions, let's use question 2. We are going back to table 1. The the three first variables that appear here are age, which is a continuous variable, a numerical continuous variable. It was expressed with a median and interquartile range. Usually, authors use mean and standard deviation, but the mean and the interquartile range are found when the data is not normally distributed, or they are some outliers. So I think that's maybe the reason why the authors use this. Here, authors did another thing, which is classified age in less than 1 year old, just to report this. For us, less than 1 year old is a risk factor for worse outcome. So it's kind of something you want to know, how many patients were younger than 1 year old. Here, this continuous variable was turned into a categorical one. Either you were younger than 1 or you were older than 1 year old. And they express it with percentage, which is fine. Male and race were also categorical variables. Male, they are both nominal. It means that they have categories, but the order between the categories is not important. There's not a natural order. So male or female, it's two options, or it's also dichotomic. Percentile, frequencies, or mode would be fine. The most frequency I think it's percentage. And then race, which had 8 categories. As I said, there was no natural order between them, and so they use frequency to express how many patients belong to each category. So for question 3, from the aim of the research question and the response in 1, do you agree with the statistical test? And here I highlight this paragraph. The author says that for continuous variables using a t-test, if the data was normally distributed, and Wilcoxon for otherwise. So let's go back to the dependent and independent variable. The independent variable were two groups, so it's categorical. And for the first primary outcome, which was measuring the sizes of the coronary arteries, we said it's a continuous variable. So for categorical independent variable and continuous dependent variable, t-test is of course the best option, and I think I would have done the same thing if of course data is normally distributed and you can meet the assumptions for the t-test. Otherwise, authors were ready to do Wilcoxons in case they couldn't meet the assumption for t-test. Then, using a Fisher exact test, unless otherwise, this part I read the entire thing, and I can jump into these conclusions because I already know this paper, but the Fisher exact actually was used for the second primary outcome. When I said whether aneurysms were developed, yes or no. So for that particular outcome, you have independent variable, which is the two groups, and again, categorical two options for the dependent variable, which is aneurysms, yes or no. For this categorical, you can use Fisher if the sample size allows you to. When you have far too much sample size, you might need chi-square. But for this, the authors could use Fisher, which is perfectly fine. I'm going to leave this little phrase for later on because it goes with the secondary outcome. So here it's the table 2 in which authors reported the result of the test. The set score, which is a continuous variable, it was tested with the two samples independent, two samples t-test. Here are the p-values. None of them were exactly statistically significant. And then the second primary outcome, which was coronary artery abnormalities, yes or no, it was evaluated with Fishers, which is okay. Here you have an independent variable, which is two groups for both of them. And here you have a continuous outcome, and here you have a categorical binary outcome. So here t-test is perfect if assumptions are met, and here Fisher exact test is also perfect. So for the secondary question analysis, and this is the phrase that I left from behind, for time from admission to initial hospital discharge using a long-rank test. So the secondary outcomes, there were two dimensions. I'm going to use these ones because it allowed me to go into another test and talk about time to event. From this secondary analysis, the authors did this a time to event. They analyzed how long it took the patients to be discharged from the moment of admission. Every Kawasaki disease has to be admitted because IgIV infusion requires you to be hospitalized. So another thing they did was this time to event. So here is table 3. Here is the median and the interquartile rate for the days of hospitalizations. And here the authors mentions that they did a long-rank test to evaluate whether there's a difference between this time to event. Another secondary analysis they did was whether patients were retreated with IgIV. For us, it's important, once we administer the treatment, patients should be afebrile within the 36 hours. When this doesn't happen, you consider this patient resistant to treatment and you have to be more aggressive and keep on giving treatment. You give again IgIV or corticosteroids or other things. But for us, this is very important because it changes outcomes on the long term for patients. Here, resistant treated patients retreated was a categorical variable, either was retreated or was not retreated. So they could use a Fisher-Exact to evaluate this, which was not significant between the groups. So the final question was, what are the parameters the authors used to calculate the sample size? So here I try to correlate what I found in the text with the colors and the information I wrote here. The alpha was a two-sided tail, significance level of 5%. The power was informed as 25%. It doesn't say the beta, but you can calculate it once you know the power, so beta must have been 15%. The effect size and standard deviation here in orange. And all of these here, alpha, beta, power, effect size, and standard deviation, because it was a continuous variable, are mandatory or the ingredients to calculate the sample size. Missing data is not obligatory, but it's kind of good to include it. You don't want to be in the middle of a trial and figure out you ran out of, you got like short or ran out of power because you have missing data and you did not prevent this. So it is of good practice. It's a good idea to take this into account in your calculation, and so did the authors, and they included the 10% of missing data. So this was the randomized trials of pulsating corticosteroid therapy for primary treatment on Kawasaki disease. I know the tests were kind of basic, but I did enjoy a lot of these trials because it's simple, it's straightforward, it was nicely done, it was easy to understand, for me at least. It was, I think, easy to understand. It had a little bit of everything, and I think that sometimes you can find really useful trials that are still simple and they give you a lot of information, even when, as this one, have negative results. It might have not tell us that corticosteroid added in the Kawasaki disease treatment is better, but it brings us far more questions to rise and to keep on learning. So I hope you like it, and well, for any feedback, I'm more than happy to hear it.